going to test transpose of a sparse matrix. What do you mean by transpose? Yes, answer fast.
Rows to columns, columns to rows.
Row to column and
Exchange
column
of I
to
and
rows.
J.
Yes, right. So whatever you are told, exactly right. Number of rows become number of columns, and number of columns become number of rows. Okay, but whether the non-zero value will going to change or the value stored in the matrix will going to change? No. What change?
No.
Only their location or address will get changed. Okay. Now that we have studied for your normal matrix representation, and how we do that, whatever the address of particular element is there, row and column address, that we just interchange, right? So for the sparse matrix, what will be the transpose? If you look at this example, number of rows are 5, number of columns are 6, and non-zero values are 6. And we have the 6 values stored at some addresses or the row and column indexes. To perform the transpose of this matrix, what we need to interchange? This rows will become number of column. This number of columns become number of rows. Agree? And this remain same. Okay. Now what is the first element? See, 0 and 4. Okay, so 0, see, ninth value will stores at row index 0, column index 4. इसे interchange करना है तो क्या करना है हमें सिर्फ? This will become
40.
40 and the value remain same 9.
Same.
Right. Getting this 1 1. If you inverse that, it will become 1 1 and 8. 2 0. It will become. It will interchange the rows and columns 0 to 4. 2 2 2 2 2. 3 5 5 3. If you interchange row and column index, it becomes 5 3 and 5. Clear with this?
Yes.
Okay. Now it is very simple.
Yes, ma'am.
Only thing, what you observe over here, what's the problem over here? See, not problem actually, but representation wise, if we interchange this, generally we start with lower rows over here. We cover all the row values. If you go with a row major, then second row values, then third row values. Are you getting me? But if you interchange this, this is a fourth row value. Okay, this is a first row value or second row value. This is the 0th row value. Are you getting me? So these are not in sequence. So क्या करना है हमें? Whether this look good or this look good. This one, actually it's not how it look. Okay, it is how we are store the values. What does sparse matrix triplet representation says? Or how we generally represent? We start with the lowest row. Are you getting me? Yes. Are you getting me? जो बता रही हूँ समझ में आ रहा है?
Yes, ma'am.
Okay, so ये भी transpose exactly correct है, no problem. Only the thing is here the 0th row become the 0th column. Okay, and here we have missed that row major. Okay, because randomly we have put the element. So instead of this, if we represent this way, modified version or modified way, this will be easy to perform the calculations. Okay, so generally when you perform the mathematical operations on the matrices, okay, you may need to deal with this way. Okay, we may increment this value and we may check with the lower indexes of the rows. But if you get this kind of result, okay, first we need to sort this based on what? Based on the rows values. 0th will be the first, then this element, then this. Okay, so we need to sort this based on rows. Okay, so this will be the correct representation or correct transpose of this matrix. Okay, so if you go in that way, हमें क्या करना पड़ता है पहले? हमें पहले से we just need to interchange this and then again we need to rearrange these things based on the row indexes and the column indexes. Getting my point?
Yes, ma'am.
Now in that case, what happened? We need to iterate this many times, n number of times, that is whatever n values are, non-zero values are there. Again we need to interchange its positions. वो करने के लिए again we need to travel this many times. Okay, and again somewhere I come across the searching करना पड़ेगा मुझे, and I need to make the arrangement for this values. Getting my view over here? Okay, so it is a time wasting and also increases the time complexity of my algorithm of doing so. I need some more resources, memory resources, some time resources to perform this task. Okay.
Yes.
So what I need over here, I need, instead of directly interchanging this 04 and storing at this location, हमने क्या किया देखो, ये element as it is इसी location पे copy किया है, and उसे सिर्फ क्या किया हमने, we have interchanged these rows and columns 4, 0 and 9. Instead of these, if I interchange, ये interchange होके क्या होने वाला है, 4, 0 and 9 होने वाला है, right? Okay? ये यहीं पे स्टोर करने से बेटर है इफ आई फाउंड आउट द एग्जैक्ट लोकेशन ऑफ दिस इन अ ट्रांसपोज. इसकी लोकेशन क्या है, ये है. आर यू गेटिंग माय पॉइंट? If I able to find out where to store this 40 in the transpose, so I directly, instead of storing here, I will directly store 409 at this location. Are you getting my point? Okay.
Yes, ma'am.
Here 1 1. What I did, I directly stored 1 1 here. Okay, 118. But ये reverse करके क्या होगा, 118. Okay, instead of storing this here, whether I should able to find out the location of this जहाँ पे ये store हो सकता है, that will be, there is no need to do the sorting and no need to rearrange all those elements. Are you getting? Now 20 20 क्या होने वाला, reverse होके interchange होके 0 to 4. Okay, so instead of storing 20 जैसे हमने यहाँ पे किया था store 02. Okay, instead of this, if I able to find out the exact location of the 02 का, it is at first location. Okay, so no need to do the arrangement later. Okay, so this is called as this this kind of transpose is called as fast transpose. Getting? Okay, so we'll see what is the fast transpose now. Before going to that, ये जो हमने ट्रांसपोज किया है अभी, ओके, दिस ऑल दिस थिंग्स, ओके, ये जो एनालिसिस है, व्हाट टाइम आई रिक्वायर्ड, देखो पहले मुझे क्या करना है, I need to interchange this and I need to rearrange this. So first I need to make the transpose and उसे फिर से मुझे rearrange करना पड़ेगा उसके. Okay, so it take a lot of time. Okay, so what is that? What is analysis? In simple transpose, we have to use two nested for loop. Okay, and as it is two nested for loop, the count will be n square. Okay, so we need to scan the array columns number of time. Agree? Columns number of time, I need to scan the array. Okay, because कितने elements हो सकते हैं, from 0 to 5. Okay, some elements are present, some elements are absent, but what is the worst case? I consider all the elements are present. So I need to scan this element or that array how many times? Column number of times, and how many elements are there in the array. So total n elements are there in the array. So what is the time complexity of this? We go off number of columns and number of elements. So maximum I consider क्या करूँगी? There are total n number of columns here and n number of elements. So maximum n number of elements, and so I can say the time complexity of this simple matrix is what? N square. Clear? So whether I can reduce this, इसमें कुछ मैं और good efficient way find out कर सकती हूँ? Then answer is yes, जो मैंने आपको बताया था. Okay, instead of doing this, we will directly identify what is the position. Okay, and that will be modified in this way. देखो मैंने fast transpose किया तो what I need, only big O of n. Why big O of n? Because what I am doing here, I am directly identifying the position of this 0, 4 here. Okay, I am not adding directly and then rearranging. What I am doing, just getting this element and placing at its particular location. It's perfect or it's ideal location जहाँ पे ट्रांसपोज होना चाहिए. Okay, getting my point?
Yes,
Yes.
ma'am.
Okay. So what I actually over here, if you see, if I use it instead of normal or simple transpose, if I use a fast transpose, I am able to do that transpose with the time complexity of big O of n, not big O of n square. Clear? How we can do that? Shall we discuss now then?
Yes.
Now here for that, shall I explain the theory part first and then example, or first we'll take an example?
Example.
Example लेते directly, because if I explain your theory, आप नहीं समझ पाओ. Excel sheet दिखाई दे रही है आपको? Yes, Excel sheet is
Yes.
visible.
Yes.
Yeah. I have copied the same example. यही example है. सिर्फ PPTs में इतना अच्छे से उसे explain नहीं किया है because of फेस लिमिट. ओके नहीं किया था. आई हैव एक्सप्लेन हियर. ओके, सो व्हाट इज द स्पार्स मैट्रिक्स? आपके सामने है. कैन यू एक्सप्लेन व्हाट इज द स्पार्स मैट्रिक्स? हाउ मेनी रोज, हाउ मेनी कॉलम्स एंड हाउ मेनी एलिमेंट्स? यस प्लीज फास्ट.
6 rows,
Six
6
column.
columns, and 8 elements.
Right, 8 non-zero elements. Okay, so this is a sparse matrix. This is a triplet representation of this sparse matrix where the zeroth rows indicate there are 6 rows, 6 columns, and total 8 non-zero elements. So these are total 8 non-zero elements. Clear? And the respective addresses of this elements are given. इसमें कुछ doubt है किसी को? Okay. So if I compute the transpose of this matrix, we know how we'll perform the transpose. We just interchange. But if you go with that way, normal transpose of the matrix or simple transpose of a matrix, we need n square. हमें वो नहीं करना है. Okay, we need a exact transpose where the already arrangement or that particular transpose is arranged with a proper way. Okay, now we'll see. In the fast transpose concept, we need to maintain 2 extra arrays. Are you getting my point? We need to maintain 2 extra arrays. First array is row terms. Okay, आप नाम कुछ भी दो. Okay, हमने जनरली जो बुक मैंने रेफर किया है उसमें उसका नाम था row terms. Okay, and second address we need to maintain the starting position. Getting this point? Okay, we need to maintain the two two arrays. First is 2 one-dimensional arrays. First one-dimensional array is row terms and second is starting position. Okay, what is row terms? This indicate total how many elements are there in each column. Okay, so total how many elements are there in each column. Okay, now we'll see. Here for explanation, if you want, if you read this, see, we maintain the 2 single dimensional array. Okay, and which are only meant for fixing the row terms. Okay, तो हमें क्या करना है? For that particular row, we see, we will count the total number of elements present at column 0. Are you getting? Because why column 0? Because these are going to be row elements. अभी जो कॉलम में है, are you getting? अभी जो कॉलम में है वो ट्रांसपोज में क्या होने वाले हैं? They are interchanged to row index. Okay, so जो ट्रांसपोज में होने वाला है, for that we calculate. Now see, at the 0th column, how many elements are there? In my original sparse matrix, check 1 and 2. How many elements are there at column 0? 2 Yes or no, students?
Yes.
Okay, then how many elements are there at index 1?
1.
1. Yeah. How many elements at index 2 with index 2? 1 and 2. I have put 2. How many elements are there with the index 3? 1 and 2. How many elements are there with the index 4? There is no element at index 4. So it is 0. And how many elements at index 5? It is 1 only. Clear with this? Yes. Yes or no? ये clear है? कैसे maintain किया है?
Yes.
Yeah. Now see. Starting position. ये इसका काम हो गया अभी. Okay. इससे हमें ये calculate करना है. Starting position. Okay. Now what is the starting position? Where to start? Where to start in the transpose? ये मुझे identify करना है. Okay. So we take the 0th element. So this we will maintain one more one-dimensional array. See, in some books they have given how many columns or what will be the size of this row terms and the column terms. This will be total number of columns present here. What is total number of columns? Unfortunately, यहाँ पे दोनों 6 है, but this will be total number of columns. Clear? That will be the size of your this row terms, and the starting position array size will be this array plus 1 generally होती है. Okay, but some books they have given you maintain the same as total number of columns. Are you getting my point? Okay, so even if you take it as a plus 1 or even equal to equal, that doesn't affect a lot. Okay, now see, don't get confused. Okay, now see, we will compute the starting position array. So what is the starting position? What is the size of this? Total number of, or size is similar as your row terms. Okay, now इसमें आपको एक basic consider करना है. The 0th value will be always 1 here. By default the value will be 1. Clear? By default the value will be 1. Clear this? So we will put the value 1 here, starting value 1 for the 0th, and we will compute the next. What will be the next value? Okay, next value will be, so I will write here, starting position of I will be starting position of 0, sorry, row terms of I minus 1 plus row terms of I minus 1 plus starting position of here also minus. Okay, now see, मुझे क्या करना है? Starting position of this 0th, जैसे मैंने कहा था, it will be always 1. Okay, now to compute the second value, we will take the this one plus row terms 0th value. What is that? 2 plus 1, 3. Getting this? Okay, so to calculate this value, I need to consider the previous value plus row terms value at 0th index. Okay, so that is 1 plus 2, that is 3. Now to calculate this 4, what I have? Previous value. What is the previous value? 3. And at the similar position, what is the row term? That is 1. So it is like that. पहले I have the 1. I have started at first. Okay, और कितने terms है total? 2. Total 3 terms will be added. 3 plus 1, 4. Okay, here to calculate this, I will delete this if you want. Get confused otherwise. Okay. To calculate this, what is the previous value? 4 plus, what is the 4 plus 2? It is 6. Okay,
Six.
to calculate this, what is the 6? Previous value is 6. And what is the value, total number of terms at this position? It is 8. Clear? To calculate this value, previous value is 8. And how many total number of terms at this position? 0. So 8 plus 0 is clear?
Yes, ma'am.
Okay, so we will get this. Once you get this, we have calculated this using the row terms. इसका काम अभी complete हो गया, इसका कुछ use नहीं है. We will deal with this now. Okay, now see. क्या करना है? हमें transpose compute करना है. Okay, listen carefully. Transpose compute करना है. Now tell me, transpose size will remain same.
Yes.
Okay. Total number of rows become total number of columns. ये हम बाद में लिखेंगे. This remains same. Okay, and this is also remains same. इसमें बाद में लिखने की कोई जरूरत नहीं. If you copied it as it is, no problem. अभी यहाँ पे ये problem है इसलिए. Otherwise, this number of rows become number of columns. Number of columns become number of rows. Clear? ये interchange हो गया. Clear this? Now see. कुछ doubt है इसमें किसी को? Yes. Any doubt is there, students?
No, ma'am.
Now we'll start transpose. Okay. Now see, what is your original matrix? This. We'll start from the first element. What is the first element? Tell me. 0 0 15. So ये मुझे स्टोर कैसे करना है ट्रांसपोज में? We need to interchange में क्या पता? 0 0 15. What will be the interchange value?
0 0 15.
0 0 15. Okay. Now what is this? This is at row 0. Okay. So I will put this 0 0 15. Okay, so इसका रो 0 है तो यहाँ चेक करो. In a starting position at 0th row, what is the value given? Is 1.
1.
So I will copy this 0 0 15 at what index of the transpose? 1. Getting? Okay, now we'll go to the next one. Tell me 0 3 22. Okay, when I interchange, what will become?
3 0 22.
3 0.
Sorry, due to network problem. Am I audible now?
Yes, ma'am.
Okay. So I will share it again. It's visible now? Yes.
Yes, ma'am. Yes.
Yeah. So 0, 3.
Yes.
0, 3, 22. What when I interchange, what it become?
3022.
30.
3, 0, 22. Okay. So what is the row value over here?
3.
Okay. Yeah, I forgot to tell you one thing. यहाँ पे हमने लिखा था 0, 0, 15 कहाँ पे कॉपी किया हमने? At 1. Okay. When I copy this, increment this by 1. 1 को increment करके रखो. What will become 1? ये increment होके क्या हो जाएगा बताओ? 2.
Yes.
Okay. Now we come to this. What is the row value over here? 3. At index 3. What is the value stored? Starting position index में देखो. It is 6. So I will
Yes.
copy this 3022 to 6. 3022. Clear? And increment this by 1. Increment होके क्या हो जाएगा बताओ? Okay. Now see. What is the next value? 0, 5 minus 15. When I interchange, what it become? Tell me fast. 5, 0 minus 15. Yes or no?
Yes, ma'am.
What is the row value over here? 5.
8.
Check at 5. What is it?
8.
8. So at 8 position, I will copy 5, 0, and what is that? Minus 15. Okay, and this 8, this only, yeah. This 8 will be
Increment by 1.
increment by 1, right? So it become 9. Okay. Yeah. Now see. What is the next element? First 1, 1, 11. So what it become by interchanging?
1, 1, 11.
Yeah. Then I will write by interchange. Yeah. It is 1, 1, 11 only. Okay. 1, 1, 11. What is the row value? Tell me fast.
3.
It is 1, no? 1. Yeah. Here it is 3. Right.
3.
3. So I will copy this at 1, 1, 11. Okay. This 3 become 4. Clear? Clear with this?
Yes, ma'am.
Next 1, 2, 3. क्या हो जाएगा? 2, 1, 3. Okay. What we will do? We will copy this here. Okay. And यहाँ पे 1 पहले जो value थे वही रखते हैं. So that if you refer even if later, it will not confusing to you. Okay. Okay. Now see. 2, 1, 3 कॉपी किया हमने. 2, 1 कहाँ आ जाएगा? 2 की पोजीशन क्या है बताओ? 2 रो. So 2
4.
क्या आ गया? 4.
4.
So yeah. We will write at 4. What is that value? 2, 1. What is that? 3. 3 is 2, 1, 3. Clear? Next, 4 को increment करके रखो by 5. Clear? Come to next point. 2, 3 हो गया. Sorry, 2, 1 हो गया. 2, 3 minus 6. 2, 3 minus 6 क्या हो जाएगा? 3, 2 minus 6. Right? 3, 3. What is 3? At 3. Now check. At 3, it is 6.
7.
But 6 is already used. So that's why we have incremented. Now what is the latest value? 7. So at 7, we will copy 3 to 6. Clear? Next. Next what? 3 2 हो गया. 4 0. What 4 0 become? 0, 4 and 91. What is 0th index? It was 1, but now it is 2. So at 2
2.
we will add, yeah, we will add. Clear with this? Now 5 to 28. 5 to, what is a 5 to? Interchange karo pehle. What is a 5 to? It will become 2 5
520.
28. Okay. What is the index of this row? Row index क्या हो गया? 2. 2 में check करो. 2 में क्या है latest value? 5.
5.
Copy 2 5. Clear with this? Yes. कुछ डाउट है इसमें? हो गया? देखो ट्रांसपोज करेक्ट है क्या? देखो, यू चेक. Is it correct one?
Yes, ma'am.
Yes or no? Clear with this?
Yes. Yes.
So how many, what time cycle are required? Whether I need to interchange this again? No, because if you observe, it is already arranged in a row major way and in a proper way. Okay. Clear? So how many extra fields I need only? Total number of rows jitne transpose mein aane wale. Okay, that is total number of columns here, and here also total number of columns. So if you go for the space complexity, it is again reduced because I no need to maintain this triplet. If you maintain this triplet, then see 8 into 3, around 8 into 3. Okay, that many space I need, but here only one dimensional array I have used, and that is total number of rows. Okay, so the space is not that much required as compared to a simple matrix, simple transpose, and that's why it is in big of. And clear with this? Clear with this? कोई डाउट है इसमें ट्रांसपोज में?
No, ma'am.
Clear with this procedure? PPTs में नहीं है ऐसी procedure, means it is there, everything is there, but only how we are doing this is not given. Okay, so this is a very simple way of transpose. आपको सिर्फ ये एक calculations याद रखने हैं, and this is the same way we are going to write the code. What is the code first? With the sparse matrix, we will maintain the first matrix, one-dimensional matrix. There is a row terms. What will be the size of that row terms? Total number of columns in a given matrix. Say for the same size, we will maintain another one-dimensional matrix starting position. Okay. First, we'll calculate the row terms matrix. Sorry, row terms array. And what that indicate? What that include? It include total number of elements present at column value this in a original matrix. Okay. After calculating this, we will compute the starting position array, जहाँ पे by default first value at 0th index will be 1. Okay, so this is a by default value. Okay, and based on this, we will calculate the every next value by adding the previous value plus the value at row terms at similar index. Okay, so this way we will compute. Okay, starting position of I have given row terms of I minus 1, this and this. Okay, if you calculate this, we will compute, or we will start computing the transpose of a matrix. And in that transpose of matrix, what is the first step? We will take first row, that is the first element, non-zero element, interchange the row and column position. For the row value, we will check the starting position index. यहाँ पे जो value है, whatever the value stored at that index, at that position, we will copy that value in a transpose of a matrix. And second step, we will increment that position by 1. Okay. So till what? Till the size of this sparse matrix, we will compute this computation. Clear with this? Yes.
Yes, ma'am.
Okay, कुछ डाउट है
Yes,
किसी को?
ma'am.
So here fast transpose same दिया है यहाँ पे. Okay, only I have represented with the Excel sheet to show you how the algorithm will proceed for that. Then what is the time complexity of this? Total number of
Big O of n.
big of n plus big of n plus big of m. Okay, what is that? Total number of like Excel sheet में देखोगे आप. What is the size required for this? Total number of non-zero element. Again, total number of non-zero element and this m. This is 2m, so generally we will ignore the constants. Okay, so if we add this total non-zero element, okay, and total number of m, why it is total number of m? Because हम कहाँ से कहाँ तक iterate कर रहे हैं? This to this, this to this, and what is this? This is the n, total number of non-zero element, and how many times we are iterating this? M number of times, total number of columns, okay, in a original matrix. So it will be the addition. When you add this, it will somewhere 2n plus m, okay, and 2m means we ignore the constants and m we consider maximum. If you consider it is almost equal to total number of non-zero elements, that will become total number of non-zero elements. Okay, clear with this? Finally, if you come to the conclusion, we go n. And that's why generally these methods of fast transpose of sparse matrix is used in your softwares for performing the transpose of a matrix. Clear with this? So in exam, the question may be asked, explain the fast transpose algorithm or explain the fast transpose of a sparse matrix and comment on the analysis of sparse matrix. When it is asked for the comments of analysis of sparse matrix or simple transpose, it is